Welcome back to Smith Coding and Design. In the previous tutorial, we went through thread milling. Now we're ready to flip our part over and remove the hat of material that would be on the top side after the part flip. If you didn't watch the setup tutorial, please go back and watch that. I describe how we are going to use a work stop and a 1, 2, 3 block to indicate in the corner of our part for Op2. We're going to continue with Op2 using, again, the YG1 end mill just to limit the number of tools that I'm using and the number of tool changes because, again, I don't have a tool changer. If you want to use a face mill, a superfly, or anything of that nature to take the stock off the back of your part, feel free to use whatever strategy suits your needs. All right, so we're going to go ahead and switch over to our second operation. The first thing I'm going to do is go edit, and I'm just going to double check that I have from preceding setup selected, which I do, and I have continue rest machining, so that is all good. So now we'll go ahead and get into our 3D adaptive clearing. All right, so we'll go up to 3D adaptive clearing. We'll go ahead and select our 3 flute YG1 end mill. That's 3/8 shank diameter. We will click OK. We are at 7,500 RPM. We'll cut at 50 inches per minute. That gives us right around 2 thou per tooth. We'll skip over geometry since we're using a 3D toolpath. Fusion will take the geometry into consideration for us. However, we'll need to make some changes to our heights tab. So our top height is a stock top, so that's correct. We want to start at the top of the material after we flipped our part. However, we do not want to go to the bottom of our part after we flipped it. We want to go to the top surface, which would be the surface shown here with the circular pockets in it. So we will choose the model top, and we'll also need an offset, and I'll show you why here in a few minutes, but let's go ahead and continue on. Okay, so we'll go to optimal load, and I want to use 30 thousandths. I typically use around 10% the diameter of my tool. 30 thousandths is right at 8%. We're going to take everything full depth of cut, so we don't need to change our maximum roughing step down. Leaving 20 thousandths worth of stock is fine. We'll go to our linking tab. We'll change the ramp clearance height to 20 thousandths, even though we're not going to do a helical entry. If for some reason our toolpath generated with some sort of helical entry, we want to minimize the amount of air we cut. So I always do that just as a habit. So we'll go ahead and select OK. Fusion will generate the toolpath, and now we'll right click and simulate. And I will show you why we want to go change the offset. So if I just move the timeline here, you'll notice we're leaving this thin piece of stock. So what I want to do is go ahead and click exit. And we just want to go below the top surface of our model slightly so that we don't leave that thin piece of stock. So if I go to edit, we go back to our heights, and I'm just going to put in a small offset of minus 30 thousandths. So we're below the top of our model here by 30 thousandths. We'll click OK. We'll go back and simulate again. And now you'll notice that we go down and we machine around the contour of the part, not leaving any thin layer of stock. So there we are, just clearing around the contour of our part. And then we'll go ahead in a nice smooth circular motion, keeping that constant tool engagement, which the adaptive clearing tool paths are meant to do, and just clearing the stock off the top of our model. There we go. So that's good. I'm happy with that toolpath. We'll go ahead and exit the simulation. And now what we want to do is get into a facing toolpath. And again, we'll use the same end mill just to limit the amount of tools we're using and the amount of tool changes because I don't have a tool changer. So I'll go ahead and do that now. We'll go to 2D. We'll select 2D face. Again, I want to go into my tool library for my Tormach and select the YG1 end mill. Select OK. Again, we're going to run at 50 inches per minute, 7,500 RPM. We will go into geometry this time, and we'll just select the contour around the top of our part. So that looks good. We'll go into the heights tab, and what I will do is I will change the top height is no longer the stock top because we use the adaptive clearing to remove most of the material off the top of our part. However, you do remember we left 20 thousandths worth of stock. So what I'm going to do is change this to model top, and then I'm going to change our offset to 20 thousandths because that is the amount of stock we left on the top. I'll go ahead and change our retract height to feed height. So we're retracting from our feed height. Okay, so that all looks good. We'll then go into passes. I'm going to change the step over to be 50% the diameter of the tool. It's a 3/8 inch tool, so we'll adjust accordingly. So that looks good. We're not using multiple depths. It's only 20 thousandths worth of material, so we're just going to blaze through it at 50 inches per minute. Go into linking. I always do extend before retract just to make sure we don't dwell at the edge of the part and leave any sort of tool marks. We'll click OK, and then we'll simulate, see what our toolpath looks like. All right, so again, I'm just going to drag the timeline here so I have some control. All right, everything looks good so far. You'll notice there we are going all the way off of our part, which is good. All right, go toward the end here. I don't like that, so if we zoom in, it looks like we may have left a thin sliver of stock. We'll continue and see if we clean that up with another pass. No, we do not. So what I'm going to do is go back into the facing operation. I'm going to go to passes, and I'm just going to leave a stock offset of, let's say, 50 thousandths. Okay. And now we'll go ahead and right click and simulate again. And we're just going to drag the timeline all the way to the end here. And there you go. We'll go to the right hand view, and our tool is going off the side or off the top of our part, making sure we're not leaving any thin sliver of stock. So everything looks good there. I'm happy with the toolpath. All right, so now what we want to do is go ahead and set up a 2D pocketing toolpath and go ahead and remove the material for the circular pockets and make room for the magnets that we're going to glue in. So I'm going to go to 2D. I'm going to go to pocket. We'll again select our tools. I'm going to go to my Tormach library and choose the 1/8 inch 3 flute Shars end mill. So I'll go ahead and select that. We're going to be running at 35 inches per minute and 8,000 RPM. That gives us around 1.4 thousandths per tooth. Okay, everything looks good there. We'll go ahead and go into geometry, and we're just going to select all of our holes. Okay, everything looks good there. All right, and then we will go into our heights. So this needs to be edited slightly. We want our top height to be the model top, not the stock top. If we left it at the stock top, we would essentially cut a bunch of air and waste machining time. So we're going to change this to model top. All right, that all looks good to me. I will change the retract height to start from the feed height. We'll then go into passes. Again, I want to select a maximum step over that is 50% the diameter of our tool. So I will go ahead and enter that in now. All right. What I will also do is go ahead and enable a finishing pass. So we'll go ahead, pocket the holes, and finish them all at the same time. So one finishing pass is fine. We'll make our finishing step over 10 thou. I think all that looks good. We do want to go multiple depths, and we don't want to leave any stock. So I'm going to go ahead and uncheck stock to leave. Multiple depths, again, I'm slightly worried about tool deflection since we're using such a tiny end mill, 1/8 of an inch. So I'm going to change the maximum step down to 30 thousandths. Okay, that looks good to me. What I will go ahead and do now is enable smoothing and feed optimization. And we'll go into our linking. And what I want to do, again, this ramp clearance height, we want to limit the amount of air we cut. So we will change that from 100 thousandths to 20 thousandths. And I think everything there should be good. We'll go back to passes and just look over this again to make sure. All right, feed rate, finishing feed rate's fine. Finishing step over's fine. And our maximum step over is 50% diameter of the tool. Okay, I'm happy with all that. I'll go ahead and click OK. And there we go. Our toolpath has been generated. So what I will do again is just right click and simulate. We'll just step through the timeline here so you can see we just helical in and then we take 30 thousandths each time and just remove stock all the way to the bottom of the pocket. Okay, so that all looks beautiful. So what I'll do is just speed this up a little bit. Just make sure there's no collisions, make sure we don't crash our machine. Everything looks good to me, so that does it for our pocketing toolpath. So next what we'll do is similar to Op1, we'll come straight down with our chamfer mill. We'll chamfer the center hole here, and then we'll chamfer all the pockets and around the outside contour of our part. All right, so what we'll do is we'll go up here and we will select a drilling routine. We'll go ahead and try to select our tool. And remember, we want to use our 90-degree chamfer tool, so we want to select milling. And then I'm going to select my 3/8 inch lemur chamfer. So let's see if we can find it. All right, here we go. So we'll go ahead and select that tool. And then what we want to do is go to geometry. So let's go over the speeds and feeds real quick. We are at 4,000 RPM and a plunge rate of right around 13 inches per minute. So now we'll go to geometry. We will select our hole. And again, when we're drilling, it's very, very important to pay attention to our top height and our bottom height. So our top height being the whole top is fine. However, we do not want our bottom height to be the whole bottom, else we would try to plunge our chamfer mill all the way through our part, which would definitely be a crash. We would either break the end mill or damage our machine. So what I'm going to select is the whole top. And again, we're going to go down 130 thousandths. And if you don't know why I'm choosing 130 thousandths, go ahead and go 2 tutorials back where I go over some basic trigonometry with the angle of the chamfer mill and the 3/8 width, and we figure out how deep we need to go to make sure that we get the tip to line up with our 1/4 inch diameter hole. All right, so what I will do now is go to the cycle, and we just want a drilling with a rapid out. We'll click OK. And so that should be it for the toolpath. Again, we always simulate just to make sure we're not trying to, again, do something dumb like plunge through our entire part if we would have chosen the wrong bottom height. So that was way too fast. So again, we could slow the toolpath down, or we'll just use the little timeline down here to make our lives easier. So there we're wrapping down, putting that nice chamfer, and then retracting. So everything there looks fine. And so now what we're going to do is one last tool path, which is, again, we're going to use the same tool and just chamfer all of the pockets and the outside contour of our part. So we'll go to select tool, we'll go to the Tormach library that I have set up, and again our 3/8 inch 45-degree chamfer tool. We'll select OK. Running at 4,000 RPM, 20 inches per minute. Gives us right around 1 thou per tooth. So what I want to do now is go to the geometry. We'll do the outside contour of our part and then all of the pockets. Bear with me here. There we go. So now what we'll do is we'll go to our heights. So here we don't want to go stock top, sorry. We'll make this our model top. We've removed all of the stock from our part, so model top would be the right selection. We'll then go into passes, and the only thing I'm going to change here is I want a chamfer width of 15 thousandths. Alright, and I think that works for me. I'll enable smoothing and feed optimization. And in linking, I'll go ahead and make our lead-in sweep angle 45 degrees. Alright, we'll click OK. And then we'll go ahead and simulate again. And we'll just drag the timeline here. So we're just going through and chamfering the pockets. Here we go with the outside. And then we go back in and chamfer those pockets again. So that all looks beautiful to me. So that does it for our GoPro mount. I hope everyone enjoyed the tutorial series. I just got myself a micro arc, so hopefully we will get into some 4th axis parts soon. That will be interesting. It's my first time using a 4th axis, so I'm trying to wrap my head around the probing routines, etc. So I imagine once I figure all that out, we'll go through it in a nice video tutorial as well. So again, I hope you like this. Please like and subscribe, and enjoy the video of the Tormach machining here at the end. We're jumping right into our 3D adaptive clearing with the YG1 end mill, 3/8 inch diameter, 3 flute moving at 50 inches per minute. You'll notice my part is off to one side against my work stop. My work stop attaches to the side of my jaw. I'm using a pair of snap jaws with a 1/8 inch step. Ideally, I would have some sort of gauge block or another part in the other half of the vise just to ensure even clamping pressure. Again, if you don't want to do the 2D adaptive clearing and then the face after, if you want to use a facing tool like a shell mill or the Superfly for example, and just go ahead and deck the top of the stock off that way, you could do that instead of doing the adaptive clearing and then the facing operation. So again, now we're just jumping into the facing operation using the YG1 end mill, going 50 inches per minute, 50% diameter tool in terms of step over. I got a nice surface finish. I was happy with it, happy with the fog buster providing the coolant and not getting either stock and or droplets of coolant all over my GoPro lens, so that was nice. So now we're going to transition into the 2D pocketing operation where we're using the Shars 1/8 inch 3 flute end mill, again going 50% diameter of the tool in terms of step over, 35 inches per minute, and just making all the circular pockets for the magnets that we're going to glue into the back of our GoPro mount. So now we go ahead and do our chamfering operations. Unfortunately, I forgot to turn the GoPro on when we did the initial drill in, wrap it out to chamfer the center hole. That operation goes very quickly, so I was not able to capture it. I apologize for that. So now we're just chamfering around the pockets for our magnets and then around the outside contour of the part. That does it for this tutorial series. I hope everyone enjoyed. Again, hopefully soon we'll get to do some 4th axis parts, and I'll throw out some tutorials for that. Please like and subscribe, and I'll see you all in the next tutorial series. Thanks again.